Hello guys, welcome back to Science Why. As you can see, I'm working on the car today. I've just changed the oil and I've been checking the levels on there, which is a very important thing to do. But where do we get oil from, and how is oil different from petrol? Let's check it out. So you may already know that oil, petrol, plastics and even the road all come from the same place. And you may already know the answer, guys. It's of course crude oil. Okay, we need to think about why it's called crude oil, but it forms from dead sea creatures, usually in the sea, that have died, fallen to the bottom of the oceans, or covered with mud, and then been compressed over millions of years. All right, now the crude oil is a mixture, is a big mess and mixture of lots of different molecules, mostly hydrocarbons. So we're going to think a little bit more, guys, about what hydrocarbons actually are. And you might have noticed I've had in my hand a lime. I've also got here some grapes and some toothpicks. Okay, and there is a reason why I've got those. And in the spirit of this channel, I've just been looking at what I've got around the house, and my idea was just to use these to model what hydrocarbon actually is. Now, as I've said, hydrocarbon, as the name suggests, is made from hydrogen carbon only, nothing else. Okay, so to represent my carbon, I've got some limes. Okay, to represent my hydrogens, I'm going to use the grapes, because hydrogen atoms are much smaller than carbon ones, and I'm going to use the toothpicks, and you may have already guessed, to represent the bond between the carbons and the hydrogens. Now, what sort of bond is going to be represented? A little bit of revision there for you guys, and hopefully you've got the answer: covalent. Now, hydrogen only makes one covalent bond, but a carbon atom, you may know already, makes how many bonds? The answer, 4. So we need 4 bonds around our carbon atom, represented by a toothpick. So I need 4 of these toothpicks to represent the 4 bonds. But of course, if you were drawing them, you'd be drawing them like this. You would see methane at the top left there and ethane at the bottom left. But of course, these diagrams are two-dimensional. Are they two-dimensional in real life? Obviously not. So when we actually make our model of our hydrocarbon, we need to bear in mind that actually, I don't know how neatly I'm going to do this, but actually those bonds are about as spread out as they can possibly be, because the bonds tend to move away from each other. All right, so we actually end up with, if I put my 4, don't know how well I've done that, with that sort of shape, which I believe is called a tetrahedral kind of shape. But obviously on the end of all of those bonds, we have one hydrogen atom. So that is my finished hydrocarbon, and this hydrocarbon would be the very smallest one, and we would call that methane. Okay, now methane would be the first in the series, what we call the homologous series of alkanes. And now it's an alkane because it has only single bonds. Okay, now the next in the series after methane would be ethane. Now, to make ethane, what I'd have to do is take one of those hydrogens off, have a single bond to another carbon. Okay, and it's gonna, I don't know how well it's gonna hold together. And then of course on our other carbon, we would then have a further 3 bonds coming off that, obviously making a total of 4, remembering that carbon always has to make 4 bonds. Okay, I'm gonna have to hold it carefully because it's gonna fall apart. But again, if I put my hydrogens on, what I have represented there, guys, is effectively ethane. All right, with its single bonds only, 2 carbons. We need to get crude oil into a form where it can be useful. And because crude oil is a mixture, it has all sorts of different things in it. Some of them are useful, some of them are not. And we call those parts of crude oil fractions. Okay, so petrol, for example, I was talking earlier about my car. And what I've actually got here, again, I'm using household resources, guys. So I've got some old bottles, water bottles, and in this one I've got some little bit of petrol in there, and in this one I've got some oil. So I've got some oil that was what I'd used for my engine. Okay, so you can see straight away how different these two fractions are. So I would say, guys, that it's not recommended that you store petrol, oil and things like that in this way, and I'm not actually going to keep these are only for the purposes of being able to see and get an idea about what these fractions are like. So as soon as I've done with them, I will definitely be disposing of them in a safe way. But the differences we need to think of: first, the colour. The oil is darker. Oil is from a longer chain hydrocarbon than the petrol. Okay, also it's thicker, it's more viscous than the petrol. And the other things we need to think about with regards to these is how flammable they are. All right, so how flammable and how volatile. Now, petrol is very volatile. Okay, which is why when you go to the petrol station to fill up your car, there'll be signs everywhere saying, obviously, no smoking or naked flames, and you're not also meant to have your mobile phone out. So obviously, there's a battery pack inside a mobile phone, and there has been examples of those battery packs overheated and maybe causing a flame, which could then potentially ignite the petrol. So that's why they say if you go onto a forecourt, if you get out of your car and you're on your mobile phone as you're filling up your petrol, they will tell you off. They'll tell you to put your mobile phone away, a bit like we do in school, really. So they won't confiscate it though and give it to your parents, fortunately. All right. So anyway, so going back to these guys, the petrol, I was saying, is volatile, which means it produces a vapor. And quite often, if you look across as other people are filling up their cars, and you see that vapor coming up, that sort of haze that you sometimes see. I'm not sure if you know what I mean. And what's going on there is the petrol is actually vaporizing, and it's going into the air. It's going from a liquid into a gas state. Some of it's becoming gas molecules, which are then going up into the air. And we say that that's volatile. Okay, so petrol is quite a volatile fuel. It's also a very flammable fuel, and I'm going to be trying to light these two in a minute, just to give you an idea about which one is going to be easiest to light and how easy it's going to be, and what sort of flame it's going to burn with. The oil is not anywhere near as volatile. Okay, we say it's a heavier fuel, although we're not using it as a fuel in this instance, of course, because it's engine oil designed to lubricate the parts in the car. But both of these guys are examples of fractions from crude oil. Okay, and there's other fractions we can get, such as kerosene and paraffin, which are both similar. Kerosene is what we call fuel for aeroplanes, for example, and the heaviest, thickest, most viscous of the fractions is bitumen, which actually has a big part in how we make tarmac for roads, which is why earlier on I mentioned roads coming from crude oil also. So this diagram here, guys, shows the main fractions of crude oil, starting with the largest fraction, which is bitumen, moving all the way up to the smaller fractions that are only a few carbons long, so methane, ethane, propane, and butane, the alkanes there. You'll also see there, as you move up, those fractions having less and less of a boiling point, being much easier to ignite, and also becoming much less viscous. Okay, so what I'm going to do, guys, I'm going to try a quick viscosity experiment comparing the petrol with the oil. And viscosity is basically how thick. All right, so I've got here some very technical equipment. I've got a paper plate and I've just lifted it up at one end. What I'm going to do is I'm going to pour these to down the plate, and I'm basically going to make a note of how long it takes them to run down, which then could be used as a measure of the viscosity. So let's see if it works. So that was the petrol. We'll compare it. I'm not timing it, but we're just going to visually compare with the oil. Alright, so in terms of amounts, I don't know how accurate I was being. Someone's deciding to do a little bit of a cutting with a bit of sawing in the background, so apologies for that, but you can certainly see there's an enormous difference in the viscosity, because engine oil, having to stick to all the moving parts in the engine, has to be extremely viscous. So we've seen the difference in the viscosity of the oil compared to the petrol being much less viscous than the oil. What about how easy it is to light them? That is another important factor. So since it's getting dark outside now, I've got a little experiment to do where I'm going to have a go at lighting the two fuels and see which one works the best. So let's have a look. So here I've got the oil, the engine oil, and I'm going to see if this will ignite very easily. So take the lid off. A little bit of it on here. It is a bit dark. And I'm going to see if I can ignite it. As you can see, we don't have any luck igniting the oil. So I've got petrol in this one. A bit of that on there. And we'll see if that will ignite. But there we go. So you can see the difference, how that petrol is burning compared to the oil. The petrol much more flammable and volatile. So after a while it will burn itself out. Obviously, don't do this at home without permission. Alright, so we know in terms of the different properties of crude oil that the larger molecules, like oil, are darker in colour, they're more viscous, but they don't ignite as well and therefore are not as effective as fuels. So that's why we tend to favour from our crude oil, because it's more productive in terms of making profit. We favour the more flammable fractions in crude oil. Okay guys, well, good news is the car starts and it still seems to be working pretty well. Hopefully that oil change would have done it some good. I'd just like to say thank you very much for sticking with the video till the end and for putting up with me, and I really hope that you've learned something about crude oil and the hydrocarbons, fractional distillation and the properties of those different fractions, guys. In the next video we're going to look in a little bit more detail, I think, at the refinement process, particularly fractional distillation and cracking. I hope you'll join me for that one, guys. I hope to see you again on Science Why. So we're going to think a little bit more about what hydrocarbons actually are. And you might have noticed I've been So we're going to think a little bit of that. And it's an alkane because it has all double bonds. No, it doesn't. It has all single bonds. Plonker.